Good afternoon, ladies and gentlemen. This will be a continuation of Unit 0, Lesson 4. We're going to call this Unit 0, Lesson 4, Part 2. And you will find these notes in your interactive notebook, textbook, in the back page of Lesson 4. So we're back to adding fractions right here. So we're going to add these two fractions. In order to add fractions, you need like denominators, and we want to go least common denominator, and we want the least common denominator of x minus 4 and x plus 3. And the least common denominator is, since both of these are prime, will be the product of those two expressions there. So the denominator, once I go to add these things, will be x minus 4 times x plus 3. This is going to be the least common denominator. And we're going to write the x minus 4, x plus 3 here. And notice here, we want to make sure that we notice that we're adding these fractions, because on the next example, we're going to subtract some fractions. Now I have to realize, what do I multiply to x minus 4 to get x minus 4, x plus 3? I'm going to multiply it by 1 in the form of x plus 3 over x plus 3. That's just another way to write 1. And that's going to turn this guy into a fraction with x minus 4 over x plus 3. So I'm going to multiply out the top here. 3x times x plus 3 is going to be 3x squared. 3x times 3 is 9x. So this fraction here is the same as this fraction. I don't know why it won't go yellow. This fraction is the same as this fraction right here. Okay. Now I need to turn this fraction into something, this dude right here, turn him into something that has a denominator of x minus 4, x plus 3. Notice I have an x plus 3 here, so I'm going to multiply this by x. Let me get rid of this dude right here. This is kind of confusing. So I'm going to multiply this to x minus 4 over x minus 4. Okay, and the bottom, x plus 3 times x minus 4, is indeed that rascal. So I'm going to multiply 2x times x minus 4. 2x times x is 2x squared. 2x times negative 4 is negative 8x. So now what am I going to do? I'm just simply going to add the numerators. Leave the denominator go. And what do I have? I'm going to add like terms here. Looks like I'm going to have 5x squared. And 9x minus 8x is x. So this is the simplification, or the addition, the sum of these two fractions right there. Okay. And I could factor the top and see if it cancels, but there is nothing that's going to cancel. And a lot of people want to factor the top, and if you did, that would be perfectly okay. All right, so let's do this guy over here, and this is a subtraction here. And again, I need the least common multiple of x plus 2 and x minus 2. And we know the least common multiple is going to be the product, because both of those expressions are prime. So the least common denominator, or least common multiple, will be the product of those two. So let's rewrite those fractions down here. Can't use yellow. It's going to be x plus 2, x minus 2. And this guy, I'm going to write it over here. X plus 2, x minus 2. Okay. So I'm going to erase this. This has kind of been my way. Sorry. So now what do I multiply x plus 2 to get x plus 2 times x minus 3? I'm going to multiply this fraction by 1 in what form? X minus 2 over x minus 2. In like manner, I'm going to multiply this fraction here to x plus 1, pardon me, x plus 2 over x plus 2. So I'm going to do the multiplication. The bottom is easy. I already have the bottom. But now I have a binomial times a binomial. I can do that fairly easy. going to be x squared, negative 3x, negative 2x, using the full method here, plus 6. Don't forget this. This is the error that a lot of people make. This guy right here. Get him out of there. What's going on here? I don't know. I don't know what's going on there, so maybe we can deal with it. So don't forget this negative sign here. A lot of people forget that negative sign. Don't forget that negative sign. All right. So now let's multiply this up here. 2x minus 3x plus 2. Again, using the FOIL method. It's going to be 2x squared. 2x times 2 is 4x. 2x, or negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. And so now I have to subtract, and I'm subtracting this entire fraction. So here's what we have to be careful with doing here. I'm going to rewrite the denominator. What I have to do here is I'm going to subtract this entire thing. So before I subtract, I'm going to distribute this negative symbol through this entire polynomial here. So this is going to turn out to be negative 2x squared. This is the step that a lot of people forget. Negative positive is negative 4x. Negative negative is positive 3x. And negative negative is positive 6. Now I can add like terms. And I'm just going to add these like terms here. And I have x squared minus 2x. Let's put the answer in blue. Is going to be negative x squared. Got the x squareds. I have negative 3x. Negative 2x is negative 5x. Negative 9x plus 3 is negative 6x. And I have 6 plus 6 plus 12. And that, ladies and gentlemen, is indeed the answer. I can factor out a negative and try to factor that, but this does not factor. So this is the subtraction. This is the difference right here of these two guys right there. Okay, you have to be careful. Here's the error right here that a lot of people make. They forget to distribute the negative sign. Okay, so just two more examples of adding, subtracting fractions. All right. Now we're going to off to a new simplifying complex rationals. This is what we call a complex rational. So let's just call this simplifying complex. Complex rationals, because they are complex. Simplifying complex rationals. And we're going to use the idea of this least common multiple. There's two methods, and I'm only going to show you one method because it's the more prevalent method in our next course, which would be calculus, the one that will follow this pre-calculus course. So we're going to use this method first, and it's the method of multiplying by the least common multiple of the little denominators. So here I have, and this is like one of those puzzles you see, count the triangles, count the triangles. We'll count the denominators. The denominators here, if I wanted to count the denominators, and I'm going to go little denominators because I want to just talk about the little denominators, and I'm going to call them little d's. The little denominators, least to greatest, are 2, 3, and 5. The big D, the big denominator in this expression, is this guy right here. And we're not going to concern ourselves with this dude right here. This is the big denominator. We want to just look at the little denominators. And the little denominators are 2, 3, and 5. And what we want is we want the least common multiple. The least common multiple of the little denominator. So the least common multiple of 2, 3, and 5 All of these guys are prime, so that's going to be 30. That's the least common multiple of these separate little denominators. So what I'm going to do is I'm going to multiply this expression over here by the least common multiple over the least common multiple. Because I can take any expression, multiply it by 1, I don't change its value. So I'm going to multiply this guy by 30 over 1 and 30 over 1. That guy is just 1. And now I'm going to multiply. Now I'm going to use the distributive property. I'm going to go that times that and that times that. So what is 30 times 1/3? Well, we've learned to factor and cancel when multiplying fractions. So 30 times 1/3, the 3's cancel, and that's simply going to be 10. Plus, if I have 30 times 2/5, well, there's a 5 in here. The 5 factors out, it would just be 6, and 2 times 6 is 12. And now I'm going to multiply this rascal by 1/2 and then 3/5 using the distributive property. Well, 30 times 1/2 is 15. I can't forget my subtraction symbol. And 30 times 3/5, well, there's a 5 here that's going to factor out, and that's just 3 times 6, which is 18. And what does that simplify to? This is going to be 22 over -3. We want to run that positive, divide by negative is negative, so the whole thing is negative 22/3. There's another method of doing that, adding, multiplying by the reciprocal, but we're not going to use that method. We're going to use this method of multiplying by the least common multiple of the separate denominators. Okay, so let's do example 2 here. This example 2, what are the little denominators? The little denominators are x and x squared. The big denominator is this guy right here, and I'm going to just circle him, but we don't worry about that. We don't worry about the big denominators. We're only going to worry about the little denominators. Okay, what is the least? And then I want to find the least common multiple of the little denominators. Well, what's the least common multiple of x and x squared? You guessed it, it's x squared. Because x squared is a multiple of x. So what I'm going to do, same method I did on the previous guy, I'm going to multiply the top and bottom by x squared. Let's get rid of this guy right here a minute. Multiply top and bottom by x squared. Use the distributive property. Alrighty, so what's x squared times 2? 2x squared. What's x squared times 3 over x? Well, one of the x's canceled, so it's going to be 3x. Now I'm going to multiply x squared times 1 over x squared, and x squared times 5. Well, what is x squared times 1 over x squared is 1. X squared times 5 is 5x squared. So this is a really nice, easy method to simplify what we call complex rational expressions. All right, one more example here. All right. So now I have, what are the little denominators? Let's look at the little denominators. The little d's, on the little d's. There's 2 little d's, x and x plus 1. We don't worry about this big denominator, just the little denominators. And what's the least common multiple, again, of these? These are both prime, so the least common multiple is going to be x times x plus 1. So I'm going to multiply this complex rational by 1 in the form of the least common denominator divided by the least common denominator. I'm not going to I'm going to kind of put them over 1 so we see what we're doing there. Now I'm going to use the distributive property just like in the example before. So I have this guy right here times 1 over x. Well, x times x plus 1 over 1 over x, what does that equal? That's going to simply be x plus 1 plus, now if I take x times x plus 1 and multiply it by 3 over x plus 1, the x plus 1's cancel. And what do I have? Just 3x. And my division bar. Now I'm going to take this rascal, multiply it by 1 over x. If I take x times x plus 1 times 1 over x, the x's cancel. What do I have left? Another x plus 1. Now I take this whole thing times 5, and it's going to be 5. Nothing cancels. There's no denominator here. And it's going to be 5 times x plus 1. And I do want to simplify the denominator there. Okay, and we're going to simplify the top and the bottom. So let's simplify the top. It's going to be 4x plus 1. On the bottom, well, I'm going to multiply through by this negative 5x here, and it's going to be x plus 1 minus 5x squared. Multiplying this dude right here, 5x times x. 5x times x, and now negative 5x times 1 is going to be negative 5x. So now I'm going to simplify the like terms. I only have 1x squared, and it's a negative 5x squared. I have x minus 5x is negative 4x plus 1. So that's what this complex rational here is simplified to a rational expression. And that's the idea. When you have a complex rational, you want to write it as one fraction, as we did, one rational expression. So that's a little short video on Unit 0, Lesson 4, Part 2. And we'll see you later.